couple things that I need you to know how to do as far as with radicals, things with radicals. Okay? One of those is how to simplify radicals. All right? So it could be something as simple as this. Do you know the square root of 25?
5.
It's 5, right? We'll argue about that later, but for now we'll leave it at 5. Okay? Do you know what the square root of 24 is? Do you? No? I don't either. Okay? But I can't leave it in this form because it is not completely simplified. And you remember a lot of times in this chapter, the directions are going to have that word in it, completely, factor completely, simplify completely, something like that. Okay? So if we get an answer when we're doing some stuff like square root of 24, we can't leave it like that. You remember sometimes I have to teach you like the end result so that when I teach you all the steps to get there, we already know how to do this so we don't have to do this again. Okay, this is one of those days. We're going to do some really technical stuff so that in the next couple days we can actually use it. Use the skills and knowledge that we have today. Does that make sense? Okay, so think about the number for 24 for just a second. Is there a factor of 24 that you do know the square root of? What is it? 4, right? So here's what you're allowed to do with radicals. I'm allowed to change this to 4 times what? 6. I'm allowed to do that. Okay? Properties of radicals say I'm allowed to do that. Here's another thing that I'm allowed to do properties of radicals wise. I'm allowed to say that this is true. Well, didn't you just tell me you know the square root of 4? What is it? 2. Do you know the square root of 6? Yeah, I don't either. Now that is completely simplified. Now, if it tells you round to 3 decimal places or round to the 1,000th, is that what they want? No. Then they want you to put that in the calculator. But if I give you this and ask you to completely simplify it, I do not want the decimals from the calculator. I want this. Does that make sense? It will be obvious from the directions which type I want. Okay? If it says completely simplify, here's where we go. If it says simplify and round to the 1,000th, then you know I want the decimal answer from the calculator. Does that make sense? Okay. So we need to do some practice on some of these. Square root of 50. Do you know the square root of 50? Neither do I. So what can we do? We can think about factors of 50 that we do know the square root of. 25. What is it? 25 times what? 2. Okay? What can I do next?
The square root of 25 times the square root of 2.
Awesome. Do we know the square root of 25?
5.
5. Do we know the square root of 2? No. So we just write square root of 2. Does it get harder?
Will it ever turn out where we know both of them?
Oh, that's a good question. Let's see. Square root of... Probably not. And here's why I'm saying that. If I ask you for the square root of 144, do you know the square root of 144?
12.
It's 12, right? You're probably not going to think, oh, that's 9 times 16. Oh, that's the square root of 9 times the square root of 16. Oh, that's 3 times 4. Oh, that's 12. See what I'm saying? You're probably going to go from here to here, not all the way through there. Okay? It's a good question, though. I don't know if everybody heard, he said, will we ever know, like, the square root of both? Like here, we've always known the square root of one or the other, right? Okay, but here's something that might happen. Seriously. Okay. What about the square root of 48? Can you think of a factor of 48 that you do know the square root of? What about 4? Does that work? Okay, so if we say 4, then that's really 4 times what? 12. Except, isn't there a factor of 12 that I know the square root of? What is it? 4, right? So couldn't I go from here to here? 4 times 4 times 12, or sorry, 4 times 4 times 3? Yeah? And in this situation, wouldn't I know 2 of these? Now, some of you can look at that and know that it's 16 times 3. Not everybody can, though. They can see the 4 really easy because the 4 goes into 4 and 4 goes into 8. They know 4 is divisible into that number. Does that make sense? So sometimes, since we're actually trying to think this out and not regurgitate what the calculator tells us, we might get into something like this, right? If that happens, then I have 2 times the square root of 3, don't I? Well, don't I know what 2 times 2 is? 4 root 3. Now, if you happen to know that 48 was 16 times 3, we could have gotten to our answer in a lot less steps, couldn't we have? But if you didn't know that 48 was 16 times 3, we can still get to the answer through our thought process, through the act of thinking. You okay with that? Okay. Does it get harder?
No.
It does. It gets harder like this. Because a lot of people are like, why is that little baby 3 there? Okay? First of all, don't ask a mathematician about a little baby 3. Okay? They will laugh at you. Some of them out loud, some of it inside of their head. Okay? But what is this asking you to do? A cube root, right? We talked about a cube root at the beginning of the year, didn't we? With our transformations and stuff. Have you thought about what a cube root is? Well, what's a square root? Whatever, in the number inside here, we're trying to think what 2 numbers multiply together that are the same number that give us that number. Well, if it's 144, what are the 2 numbers that multiply together the same that give us that number? 12, right? So then what do you think a cube root would be? Yeah. What times what times what? The same number 3 times that will give us that number. So it makes us think a little bit more, right? 8. In this case, it's 8, right? So we have the cube root of 8 times 2, which means I have the cube root of 8 times the cube root of 2. Do we know the cube root of 8? It's 2, right? This is a 2. Do I know the cube root of 2? No. Cube root of 2. Questions? Anybody? Is it just what? It's 2 cube root of 2. Like, that is the whole answer right here. That's the answer. You still have to have that 2 in the front because we got that 2 in the front from taking the cube root of 8. Does that make sense?
Yeah. Wait, what happened to the 2 is the cube root of...
Oh, yes. Did I not make that clear? I apologize. Thank you for helping out. Okay? We got this 2 right here by taking the cube root of 8. And then we got this cube root of 2 because we don't know what the cube root of 2 is, so we just write down cube root of 2. What do you think? Okay so far? Okay, now here is the really hard part. Because a question will ask you, well, what is the cube root of 7 times the cube root of 5? Wait, is that a really hard part? If we can take it here and go to this step and then that step, why couldn't we go backwards? Is that allowed? Yeah, absolutely. What can I do with this then? Properties of roots, of radicals, say that I can do this, which means my answer is the cube root of 35.
That's it?
Yep, that's it. Because there's no factors in 35 that I know cube root of. Okay? Remember this chart over here?
Yes.
I do not, absolutely do not want you memorizing this chart. I would like you familiar with this chart. I'd like us to be doing a problem and you get a number of 216 when we're doing a cube root. I want you to notice 216 and be like, oh, that's something. I don't remember what it is, but it's something. I want you to be familiar with that number. Do you see the difference? Because if you're familiar with it, if you're like, oh, 216, oh, okay, 216, the cube root of that is 6. Oh, okay, 6, got it. Right? I want you to be able to go this way, but I also want you to be able to go this way. For the record, guys, I don't have this chart memorized at all. I know my squares just because I've been doing it for a while. Okay? And when I was creating this chart, I knew that much of the cubes. I just happen to know those in my head. But the fourths, I knew that much. That was it. Okay? Like I said, because I've been doing this for a while. That's the only reason I know those. I do not want you to try to memorize this. Unless you just get grounded for 3 weeks and want to do something. Then you just go right ahead. Okay? I just want you familiar with this. I want you to be able to refer back to this. Do you know how to read this? Do you know what everything means here? If this is the x number, that's that number squared. That's that number cubed. And that's the number to the fourth power. Excuse me. Okay? So if I say, what's the fourth power of 625, what do? 625, it's 5. What if I say, what's 6 to the fourth power? What do? 6 to the fourth power, 1296. Does that make sense?
No, right. Oh, I looked at it.
Yes?
Yes.
Okay. So we'll refer back to that. Not to worry. So another thing you've got to be able to do is go back and forth from radicals to exponents. If you'll remember, when we did our foldable yesterday, one of the things that we put on the very back was this. A to the m over n power, and we said the numerator of the exponent was the power, the denominator of the exponent was the root, right? So what if I said to you 16 to the 1/2 power? What is 16 to the 1/2 power? If that's the power and that's the root, what are they asking you to take? The square root of 16. 16 to the 1/2 power and this, don't they mean the same thing? This one's in exponential form, this one's in radical form. Okay? So what is 16 to the 1/2 power? 4. What is 8 to the 1/3 power? It's 2. Because remember it's asking you to take the third root of 8. Okay? Now, I'm pretty sure we had this talk at the beginning of the year, but I want to have it again right now just in case. Okay? This symbol, this sign right here, is not a square root sign. Remember what that's called? Yeah, it's called a radical. Remember that? We talked about that when we were talking about transformations at the beginning of the year. Now, sometimes I say the square root sign. We got the square root sign here. I'm being lazy with my vocabulary when I do that. Okay? But when I say square root sign, you guys all know exactly what I'm talking about, don't you? Don't you? Yeah? Okay? Because, why is that? Why is it? Isn't that what we always use it for? Up until now, haven't you always used this to take the square